Hello, welcome to Science Jump. Today we're going to be looking at circular motion. A couple of things that we need to know before we start. We have speed as distance divided by time. Now, even though this isn't really related to circular motion, it helps if you understand this equation here. Secondly, we need to know what basically a circle is. A circle is like this. You have a radius. When you have double the radius, like so, we call that the diameter. So that sometimes comes in useful. And we also have a circumference which goes all the way around, like so. And one thing that we got to know about this is you always have an acceleration towards the center, and the velocity is at a tangent. So your velocity is at a tangent. Now, what that means is if it's going round in a circle, the acceleration is always towards the center, and the velocity is always at a tangent like this, right? And that acceleration causes the velocity to change direction. Now it doesn't speed up, it just changes direction, so we call it uniform circular motion. And that's true for any point. So acceleration is towards the center. I've drawn that badly, but okay. And your velocity is at a tangent like this. So this is your acceleration. Now this acceleration they call centripetal acceleration, meaning it's center seeking. And the force is also towards the center, and it's center seeking. Okay, so let's just get a few more equations down. Now, if you know anything about circles and maths, you know that the circumference is the distance all the way around. And since we've got distance divided by time, it sort of stands to reason that your velocity at a tangent, your VT, tangential velocity, is going to be the circumference. Now the circumference is going to be 2 pi r, so 2 pi r, but that's just the distance, divided by the time. So that's your first equation. Okay, the acceleration, and we say a CP for centripetal acceleration, v squared divided by r. Now, this is quite interesting because if you double the radius, this becomes half. If you double the velocity, the acceleration gets quadrupled. If you double both the velocity and the radius, then this doubles. Okay, so that's the relationship between those. I might use a different color because I don't want things to start clashing. Now, you've also got F equals ma. This is Newton's second law. Now, since A is this, we can also extend this to F equals mv squared divided by r. Okay? And since this is 2 pi r divided by t, if we square this, we end up getting, now if you square 2, you get 4. If you square pi, you get pi squared. If you square the r, you get r squared over t squared. But we've also got divided by r. Now, this divided by r and this kind of cancels itself out. So you end up with acceleration, centripetal acceleration. It's 4 pi squared r divided by t squared. Okay, so we've got that many equations. We've also got one more thing about time. I'll put that in a different color. Time is the time taken to go around that, and that's 1 divided by the frequency, and also the frequency is 1 divided by the time. Now the difference between frequency and time is the time taken to go around in a circle, and the frequency is how many circles you get per second. This is measured in hertz, and time clearly is measured in seconds. Okay, so now that we've got this all out of the way, let's tackle some questions. Actually, before I do that, I forgot to mention one thing, okay? Examples of centripetal force, okay? In the case of, for example, a car going round a circuit, it's going to be friction. In the case of something being swung around on a piece of string, it's going to be tension. And in the case of a planet going around the sun, it's going to be gravity. Okay, that's all of the basic information that we need. Feel free to pause it, go back, look at the equations again. Let's tackle some of these questions. An athlete performs a hammer throw. The mass of the hammer is 7.26 kg. Its center is 0.5 meters from the thrower and is moving at a speed of 1.5 meters per second. Calculate the centripetal acceleration. And for part B, what is the tension in the chain? Let's get that solved. Okay, so the first thing that we do, always, we write down everything that we know about this particular thing. So mass, M, equals 7.26 kg. Radius is 0.5 meters. VT, that's tangential velocity, is 1.5 meters per second squared. And we want to work out acceleration, centripetal acceleration. Okay, so very simple, very straightforward. We look at our equations, we want acceleration. So we've got v squared divided by r. Let's do that. V squared and r, we have both of those things. So A equals v squared divided by r. V squared is going to be 1.5 squared divided by the radius, which is 0.5, which is 4.5 meters per second squared, or meters per second. Okay, so that's part A done. Pretty easy. Let's look at B. Let's use a different colored pen. And that's what is the tension in the chain. Now the tension is the centripetal force, so FCP, centripetal force. And if you have a look at our equations, there's two that we can use. We can use MA and MV squared over R. Now, clearly we've got MV and R, so we've got MV squared over R, but I've already worked out the acceleration. So simply just take the mass multiplied by the acceleration. F equals MA. That's Newton's second law, in case you're wondering. So that's 7.26 times 4.5, which is 32.67 newtons. Great. Okay, let's have a look at our second question. A 615 kg car completes one lap around a circular track with a radius of 50 meters. The car moves at a constant speed and completes the lap in 14.3 seconds. Calculate the acceleration and what force must the track exert on the tires to produce this acceleration. Great. Now, that one's a little bit more complex than this, and you'll see why. First of all, we've got the mass, we've got the radius. Don't know the acceleration. We actually also have the time. If I put this here, the time is 14.3 seconds, so let's put t over here. Okay, here are our equations. So what do we need? We need the acceleration. Can we do v squared divided by r? We can't because we don't have the velocity. However, can we do 4 pi squared r over t squared? 4 pi squared r, yeah, over t squared. We can definitely do this one because we have the time and we have the radius, and pi, as you know, is a constant. So let's use that one. So acceleration equals 4 pi squared r over t squared, like that. Right, so that's 4 pi squared times 50 divided by 14.3 squared, which is 9.65 meters per second squared. Okay, and then the next bit's dead easy. What force must the track exert on the tires? So just as before, it's Newton's second law, F equals ma, or you could do mv squared over r, because now actually we can't because we don't have the velocity. So anyway, let's work it out like this. M times A, M is 615 times 9.65, 5,936.5 newtons. Now, just for fun, what we could do is we can try to work out the tangential velocity. We haven't done that one yet. So let's put here VT. So that's our next one. So we can do 2 pi r divided by t. Perfect. Okay. So VT is 2 pi r divided by t. That's 2 pi times 50 divided by 14.3. 21.97 meters per second. Easy. Easy. That's exactly how you do it, okay? So nothing really massively complex. Just write down everything that you know and then look at the formulae and then go from there, okay? Oh, by the way, before I say thank you very much and goodbye, if you can donate, like, share and subscribe. I need the funds. Too much of a brokey right now, but we're doing well. We're at 4,900 something subscribers. Need to get to 5,000. You can make it happen.